So we have a two-port network and a voltmeter is used to measure the output voltage. Now the voltmeter has a sensitivity of 20 kilo ohms per volt, and there are two voltmeters basically, with the same sensitivity, of course. With the one has a range of 0 to 10 volts. When that is used to measure the output voltage, the reading that is found is 4 volts, and the other voltmeter, which has a range of 0 to 50 volts, the open circuit voltage is 5 volts. So we have this information. We need to use this information to find the Thevenin's equivalent of the circuit. So we do have the voltage sensitivity, and when we say about the Thevenin's equivalent, so we are looking for this one. This is Thevenin's voltage, and then we are looking for the Thevenin's resistance, and we have the voltmeter here, which does have a finite resistance. It's not infinity. It's a real real world voltmeter, not an ideal one, of course. It's just a real apparatus, so it does have a resistance, and we need to find what is the resistance. So this is the sensitivity, and when the voltmeter that has a range of 0 to 10 volts, we can use the equation. So sensitivity times the maximum voltage of the range, so that is 20 kilo ohms times 10, which is the maximum voltage of the range, is 200 kilo ohms. So that is the resistance that it possesses. So since it is open circuit, we can just apply this resistance here. If it were not an open circuit, if there was another resistance, say here, which is across which the voltage was measured, then we would have to put it in parallel, and then we have to calculate the equivalent resistance, but we don't have to do that since this is an open circuit. So this is there, 20 kilo ohms, and we have the voltage here, which is 4 volts. So we have this information. Then again we will have another situation when, for the other voltmeter, it will be R Thevenin here, and the resistance will be what? In that case, the sensitivity is the same, 20 kilo ohms per volt, but we need to find what is the resistance now. In this case, it will be 20 kilo ohms times, now the range is 50, 0 to 50 volts, so the maximum voltage is 50, so 20 times 50, so which is 1000 K or 1 mega ohms. So I'm just writing 1000 kilo ohms here. So that's there, and now the voltage is 5 volts. So that's the measured voltage. So we have this information. So I will just write an equation. The 4 volts voltage can be found by voltage divider rule. So here we have V Thevenin, which is the total applied voltage, times, of course, it will be the voltage across which this is measured, and this one will be R Thevenin plus 200. So that's the voltage divider rule gives me this voltage. So if I multiply, it becomes 4 R Thevenin plus 800 is equal to 200 V Thevenin. So that's my equation 1. And if I use for the other voltmeter, that is, the voltage here is 5 volts, so if I again apply voltage divider rule, it will be V Thevenin times the resistance across which it is measured. This time it is 1000 kilo ohms, and R Thevenin plus 1000 it is. So it is becoming, if I multiply 5 R Thevenin plus 5000 is equal to 1000 V Thevenin. So that's my second equation, equation number 2. So now if I multiply equation 1 by 5 and then subtract 2, what I get is here I will get, so I'm trying to getting rid of V Thevenin in this case. So 5 will be 20 R Thevenin plus 800 times 5 will be 4000, and here it will be 1000 V Thevenin, and here it is 5 R Thevenin plus 5000, and this one is 1000 Thevenin. So basically if I subtract, the 1000 Thevenin will get cancelled, so this is 15 R Thevenin minus 1000 equals to 0. So R Thevenin will be 1000 over 15, which is 66.67 kilo ohms. So that is my R Thevenin. Now in order to find Thevenin, I can just rearrange one of the equations. Let's rearrange equation 1. So that is 200 Thevenin is equal to 4 Thevenin plus 800 here. Thevenin, that's, so Thevenin is now becoming 4 times 66.67 plus 800 over 200. So if I do that, I get Thevenin as 5.33 volts. So that's the Thevenin. So with this information, we can find the Thevenin's voltage and Thevenin's resistance, which is basically the line resistance of the circuit.